And we're already talking a little bit about the future. So how would you see the future of reliability engineering and chaos engineering?
Yeah, I think things are definitely going to change a little bit. It's going to be, I see chaos engineering potentially go into an agent mode, like with autonomous agent that, are able to inject faults at the right place. Obviously linked with observability is the right place to do chaos engineering. And then, AI is there, right? You inject faults, you understand the system, abstract complexity, and then potentially make changes, right? So adaptability. So I think it's going to be a big part in there in making giving the data to agents to create adaptability. I think that's where chaos engineering is potentially as a good place. It just means we need to be able to do chaos engineering very, very simple, in a very simple way, almost hands off, potentially all autonomous, and then potentially as well in an accelerated way, right? So that's why I think about those deterministic simulators that are interesting. Not everything can go into those simulators, and eventually the real world systems are a bit different. But then how could we use those principles of accelerated learnings, automated load, automated, synthetic users. So you can have a phase of really, test the whole system, inject chaos with load, all that kind of stuff. That gives you a data set of how your system is supposed to work. You put this into AI, it creates this 3D image, of how your system is and all the boundaries, and then you can make good suggestions based on the context of where your business is going. Does it make sense what I'm saying, or is it?
Yes, I'm following. Yeah, it makes sense. Absolutely. So we all know that we are not getting out of this complexity cycle, and we all need to learn and are getting more insights about it. Is there something you can already, some recommendations for reading and learning? So if people want to get started with such complex systems, or also like the human part in those systems, is there something from your reading list you want to share?
I mean, the classic Woods, kind of about resilience engineering are a great start in resilience engineering in practice, human errors. A lot of the book from I think is Diane Vaughan about the Challenger, where she talks
project.
about the normalization of deviance. I think that's also super interesting. Interesting idea. It's changed me a lot. And then just there's no substitute to trying. I think hands on, and actually because you can read as much as you could, but at the end of the day, you just need to try things and play, because that's where you get the real value. And again,
and the biggest learning for yourself. So really learning from failures, learning from you're doing this right now is so valuable.
Yeah, and I would also say, and I know it's ingrained in all our brains, learning from failure, but you can learn a lot from success. I think that's a big miss in the industry. Everybody focused on learning from failure, but most of the time the system works, right? And there's a lot of learnings to be done during success, right? So when near misses, when things are just nobody talks about, but your engineer reviewed something in the code or did an operation that prevented a big outage. All these are so important to learn from, because they are 99% of the time it works, and understanding that is a very important thing, because if you only focus on failure, you focus on 1% of the time and meet those problems, and that's great, but there's so much to learn, and then piggyback on what works and make it even stronger.
I would agree, but this also, there's a strong need that you, for example, if you have implemented like a specific fallback strategy, or maybe you would like to see your retry pattern, you need to see it in the data. If the system is just running and you are not getting any insights, and you need to get this confidence, you need to see that what you have created is really working. And if there's an edge case, or like this fallback should now been called, you need to see it in the data as well. Otherwise, you are just guessing.
Yeah, for sure. There's no doubt about that. But I think it's still a lot to learn from when things work properly, right? And then understanding why they work, because Like it, because at the end, otherwise you're gonna have a failure. You're gonna fix something, and it's gonna affect things that already work, right? I've seen this a
Correct.
lot. I've seen this a lot. It's like you focus on something that didn't work, you try to address that, and then it touches something else because nobody saw that, oh, that something else actually was successful. And I've seen this a lot as well. It's interesting to think about it, right? So it's just like a note. I know we always, it's part of the chaos engineering to always talk about failures, but I think understanding success and, using chaos engineering actually to also show that your system behaves well in a hard condition is such a great thing, right? So it shouldn't be like just put on the side, because if you can just prove that your system works as you expect, it's great. It's a great way to sell. It's a great way to sell.
Yeah, and you can be really proud about it, that the system is working as expected, because that's like you want to see your expectation fulfilled from the system as well.